And now I would like each of the panelists to introduce themselves. Abbe.
Hi, my name is Abbe Herzig. I am the Director of Education at the American Mathematical Society. Thanks for joining us.
Rena.
Hi everyone, I am Rena Levitt. I'm a professor of mathematics and the head of the College of Computational Sciences at Minerva Schools at KGI. We're a small liberal arts college, and all of our classes are taught remote by default.
Francis.
Hi, I'm Francis Sue. I'm a professor of mathematics at Harvey Mudd College, which is a liberal arts school of science and engineering in Southern California.
And Shell.
Hello, everybody. I'm Shell Younker, Chair of Mathematics at Owens Community College in Ohio.
And finally, Kate.
Hi, this is Kate Stevenson. I'm a math professor at California State University, which is a large comprehensive master's granting university. Nice to be here.
And you can see that our panelists come from a wide variety of backgrounds. And so when you hear about these formative assessment ideas, we're sure that there's something that you can use in your own classroom. And we'll begin with Abbe.
Hi, everybody. Can you go to the next slide, please, Nan? Which I can't read, but okay. So in order to talk about assessment, I want to propose this as a working definition of assessment. That assessment provides both instructors and students a window into their learning and their progress toward course learning objectives. And in particular, for students, it helps them understand, have I learned what I need to learn? And it gives them that feedback so that they can then adjust accordingly if needed. Now there's, implicit in the first sentence is the idea that you have course learning objectives. Next slide, please. So one model for thinking about how to build course objectives and assessments and classroom experiences is to start by identifying the desired results. What do you want students to be able to know and do at the end of the lesson, the unit, or the course? So instead of thinking about, I need to cover chapters 1 through 9, to really identify, I want them to understand that a derivative is a rate of change or something like that. Based on, once you have course objectives, which is really what you want them to know by the time you're done, then you can think about what evidence do you need to see in order to believe that they have achieved what you've set up for, what you've set as your goals. And then based on the assessment evidence, you can then plan learning experiences to get them to that ability, to be able to produce that evidence for you. And a very important idea is that you identify your learning goals, but then you align assessment and learning experiences so that you're really thinking about your goals and how you can get the students there. Next slide, please. So we're talking about formative assessment today, but just so that we understand the difference between different types of assessment, formative assessment is a form of assessment that occurs throughout a class or course very, very frequently. And the idea is to improve students' growth toward the objectives that you have and to give them feedback about how they're progressing toward those goals. It's not only feedback though for the student, it's also feedback for the instructor. If you see that lots of students aren't understanding what you hope they understand, that gives you an opportunity to change course a little bit if you need to. And formative assessments can be either graded or ungraded. Summative assessments are those things that we assign at either the conclusion of course or a conclusion of a unit often. They're things to measure what students learn. So it's more of a measurement device, and they're usually graded, and often in mathematics they're heavily weighted, which doesn't need to be the case, but that seems to be our cultural assumption in mathematics. Next slide. So when you put together that little flow chart at the beginning with this idea of formative and summative assessment, it looks something like this. You start by identifying your learning goals all the way at the left, and then what assessment evidence you need in order to know that your students are getting where you want them to get, and then you design your learning activities. as you're doing the learning activities, you do some formative assessments, which is really telling you what they've learned. It tells that to you and it tells that to them. From there, you can reflect and they can reflect on what they're learning and understanding, which might lead you to revise your learning activities or move on to the learning activities you have. And so you move through that cycle throughout your unit or throughout your semester. And then periodically, when you want to record really where they are, when you want to measure their performance, then you would have summative assessment. Next slide, please. So I'm going to provide an example from a course that I taught. This is a very simple mathematical example. It's from a course for elementary teachers. And so I started with the learning goal that students will be able to solve mathematics problems by applying reasoning and critical thinking skills. That is, I was moving very clearly away from rote procedures. That was a very important goal for me. And the evidence I looked for is that they'll be able to provide detailed solutions and justify each step, that they can't use procedures that they can't explain. So the learning activity I designed to do that was I had them solve a non-standard problem. They shared their solutions with each other in an online platform called VoiceThread, and then they compared each other's strategies. So they all had to post their strategy and respond to each other. So this is the problem I gave them. Who gets more cookie? A child in a class where 22 children are sharing 18 cookies, or a child in a class where 7 children are sharing 6 cookies? The cookies are all the same size. Now, you've probably all figured this out by now, before I even finished reading the sentence. But for students who are being asked to justify every step, many of whom don't really understand the details of the math that they know how to perform, this can be kind of challenging. In particular, they're not allowed to cross multiply and divide, because none of them know what that means. Many math majors don't even know that. If they want to use common denominators, they have to explain what that means. And I'll show you some examples of the strategies. So the formative assessment part of this was they posted an initial solution to VoiceThread, and I'm going to show you some examples. VoiceThread allows them to actually, it's an asynchronous platform, but they can actually record their voices. So they would each narrate their strategy, and then they would challenge each other by asking for clarification, or what did you mean here? Or I think you overlooked something there, and helping each other develop their strategies. And then the summative assessment at the end of that is that they had to submit a written solution. And it didn't have to be the strategy that they first developed. They learned something maybe from looking at someone else's strategy, and they had to submit it and justify every step. And in this case, I'm not so interested in, did they get the answer right? I'm really interested in the type of thinking that they're doing. And you could imagine perhaps doing this model with something like writing proofs, right, in a more advanced class. Next slide. So I set these ground rules for them. And this is exactly what appeared in the assignment. Be creative, step outside your comfort zone and try something new. Go beyond how to solve it to why your solution makes sense. Do not use standard algorithms or rote procedures unless you can justify why they work and why you should be using them here. Your explanation has to be detailed enough for us all to understand. And we're not looking for right or wrong, but for the clarity of your explanation. And I expressed to them the learning goal to gain experience in solving a problem based on your own reasoning rather than using rote procedures. And with every assignment, I state that learning goal to them so that they understand what it is that we're aiming for. So here's one. It's probably too small for people to see, but the person starts at the top by writing 18 over 22, and she then divides the numerator and denominator by 2, so she gets 9/11ths. And then she decides she needs to compare 9/11ths and 6/7ths. She writes out she calls them factors, but what she means is multiples. So that would be so she writes 11 has multiples 11, 22, and so on. She calls those factors because she knows she's trying to find a common factor. But this opens the opportunity for me to see she doesn't understand the vocabulary, and she's going to become a teacher. I want her to have the correct vocabulary. So she does this thing about finding common denominators in the middle there. And she would also maybe be challenged to explain why can you multiply the numerator and denominator by the same thing. And again, I know this is very simple math for all of us, but what you'll see some students at this level write is anything you do to the numerator, you have to do to the denominator. So then we talk about, well, really not anything, right? That this works for multiplication and division, and why is that the case, and get them to explore that. But the other thing that's really interesting in this solution at the bottom is she drew a scale model. And she lists there that her scale is that 2 millimeters equals 1/77th, I think. So she really went to the effort of measuring that out carefully. Lots of students drew tape diagrams like that, but it's really hard to draw 77ths or 11ths to scale unless you measure. And so some of them misused diagrams like that because they couldn't really draw them accurately. So it was pretty interesting that she did a scale model in here. Next slide. So this person also drew a model and tried to compare the length of things, but again, comparing them was not really an accurate way to go because she didn't do anything to scale. She compared these two ratios to each other, and she actually used units, which not many of them did. And I'll show you an example in a minute that someone who lost the units and therefore didn't understand what their solution meant. But this person looked for a common numerator. And actually several of the students did this. And other students commented, oh, I never thought you could do that. And then she gives an explanation at the bottom that the larger the denominator, the smaller the parts. Since they have the same number of parts, the fraction with the smaller denominator is bigger. So she's explaining why that principle works. Next slide. This is one of my favorites. This is actually not from my class. This was done by a second grader. This is my picture of what the second grader described. And this is basically the beginning of proportional reasoning, right? He took the class with 22 children and he said, well, let's try to match them to 7, the ratio 7:6. And he found out that, that there were too many children. He was left with 8 children with the final set of cookies, whereas all the other sets of 6 cookies had only 7 children. So he concluded that class 1 had more cookies per children. So this is really interesting because this is the foundation of thinking proportionally, even though he's only in 2nd grade and wouldn't use that language. He's starting to look at ratios among things. Next slide. So here's the person who got messed up with units. She actually put children over cookies, which is valid, but she didn't keep track of the fact that she was doing that. So when she divided and she turned things into mixed numbers and decimals, but because she didn't keep track of her units, she thought she had cookies per child when she really had child per cookie. So she reached an incorrect conclusion. So what I can see by looking at all these different strategies, and this is just a sample out of a class of about 25 students, is I could see what they do and don't understand. And then as they would ask each other questions and discuss their solutions through VoiceThread, or they could do it in a discussion forum in Blackboard or whatever your platform is, they start to challenge each other and they start to correct each other's misconceptions or learn from one another. When someone explains how converting a fraction, a mixed number to an improper fraction, how that works and why it works, that it's not just multiply the denominator by the whole number plus, but really why that rule works, they start explaining those things to each other. And as they're all learning from that, I'm able to see what they really understand and what things I need to reinforce or might need to challenge them on. And I usually do that by going in and asking questions. Like if one of the students hadn't done it, I might have said to this person, why don't you look at the units you're using? Why did you set that up, and what does that 22/18 mean? And try to get the student to work their way through whatever misconceptions are at play. Next slide. So these are just some quick formative assessment strategies that I wanted to share with you, and you're going to hear more detail about those from all the other panelists. One of the things that's really important in these is the verbs that are used really require them to do something. It's not just solve this problem or what is the answer to this question, but to reflect, to explain, to connect, to justify, to confirm, to summarize. I really like number 7. I just learned that one last week from somebody. He said that he assigned at the end of every class what he called the muddiest point essay. And they had to submit something brief that was just what was the thing in the lecture or in the assignment that was the least clear to you. So that forces them to reflect on it, and it also gives him feedback on what's going on within the class. Next slide. And just a couple of other strategies. Some people use minute papers, which is a little harder to do online. The idea in a face-to-face classroom is you give people something, one of these formative assessment strategies at the end of class and give them 1 minute. In Zoom, you can do some polling and just say, you know, how many people think that a derivative means X, Y, or Z, and then you can share those results with the class through that poll and get into a discussion around it. 3, 2, 1 exit ticket, I really like that, asking them to reflect on their learning. What are things I learned, things that were interesting, and what's a question I still have? And one person recently told me this too, that he uses a Twitter model, you know, gives them a very succinct amount of space in which to summarize something, whatever it might be. And this link, the slides will be shared later, but this link is to something called Classroom Assessment Techniques, and they have I think something like 50 of these little models that you see in front of you. So that's it for me. I see a hand raised. I think that we were asking people, instead of raising hands, to enter your question in the Q&A, please.
Right, and Abbe, you have 2 questions. In formative assessments, is it a good idea to test more than one idea in the same question?
I think you have to be careful about doing that with formative or summative assessments. You can do it depending upon what you're asking the students to do, but if you're only looking at an answer being right or wrong, if you have 2 concepts in there, you don't know what they do and don't understand. Did they not understand the notation, or did they not understand the concept, or did they not understand how to do it? So I think you need to be really careful when you're constructing these kinds of assessments, that you really understand what feedback you're actually getting for yourself and for them.
And Abbe, one other question. How were the students posting their solutions on ViceThread? Was it by taking pictures, scanning them, and uploading? Was it very time consuming?
Most of them just took pictures, I assume, with their phones and uploaded them. Some of them put it on a PowerPoint slide. Most of the times, if it was a PowerPoint slide, they had taken a picture and then put that on the PowerPoint slide and then wrote out words that they wanted to go along with the picture. I don't think it was terribly time consuming. The time consuming part was solving the problem the way I asked them to solve it. VoiceThread is a wonderful tool because it's still asynchronous, but they get to talk to each other. It's a little clunky to learn, but it's not extremely intuitive, but they offer some really great trainings, and it's, I think, a wonderful tool.
Okay, thank you. And now we'll move on to Rena.
Hi, everyone. So today I wanted to talk a little bit about how you can embed formative assessments into your courses directly. Next slide, please. So I'm going to talk a little bit about a type of formative assessment that you can do before the semester. And this is really in order to collect data on your students so that you can make adjustments and think about how to tailor the course into the incoming class. So diagnostic interviews or surveys. And then I'm going to talk about what you can do during the semester, frequent low-stake quizzes, and also student observations. These are both techniques that I use in my courses, both in what I've taught in brick and mortar institutions and also in the virtual classroom I teach at Minerva. Next slide, please. So let's talk about the pre-semester diagnostic assessment first. The idea here is I want to learn about what my students are coming into my course with. So I want to gather information about their backgrounds and interests. That could be previous relevant coursework, student levels, their degree plans, and their majors. So to get an idea of maybe the demographics of my students as they're coming in. I also use this as an opportunity to direct them to think about their own motivations and goals for taking my course. So yes, maybe they're taking my linear algebra course because it's a requirement for their degree plan, but also what are they looking to get out of it? Is there a specific concept they're really excited about learning? Is there a skill that they want to grow over the semester? Help them set those goals and share those with me so that I can I can provide support there. I'll also ask them about plans for engaging with the course material, especially with our students being remote. I think this is really important. Are they planning on taking as much of the course as possible asynchronously? What time are they planning on working with it? How much time do they think that they're going to need in order to solve problem assignment or problem sets? This is a chance for me to really think about how they're going to do that. And then also asking them about the constraints while they're remote. Are they sharing their workspace with their family or with the people that they're living with? Do they have access to computer and Wi-Fi? What sort of challenges might they be trying to negotiate there? What responsibilities might they have outside of coursework? Maybe right now they're taking, well, whether even outside of a global pandemic, maybe they work a job, maybe they have childcare responsibilities, especially my students are undergraduates, tend to be younger in the model, but maybe if they're home with their families and taking class from there, they have childcare responsibilities or elder care responsibilities. So what else are they trying to juggle, right? Maybe they have this like great internship that they're working on. So I'd like to get in a better idea of all of that. And then finally, I tend to use this as an opportunity to gauge my students' preparation for course material. They could tell me that they've taken the course, their previous coursework, and that can be relevant, but I want to know what they've retained and what they're coming in with. And often I try to think about asking them questions that go beyond sort of that algorithmic approach to solving problems, to have them again reflect on how well they can do things. So an example is for my linear algebra course, I might ask them how they've encountered matrices previously, how they've applied them, what methods they might know in order to solve a linear system of equations, right, with a description of that method. And then I'll actually ask them to pick one that they like to use and apply it. So maybe they really like to use substitution, maybe they really like to use elimination. I want them to show me how to do that and apply it. And this can give me an idea of what students need to work on and how I can tailor the course. Let's see, how have I done this? Sometimes I do this as a survey before the class, which I'll send out to the students maybe with a Google form. Sometimes I have done this as a pop quiz on the first day of class, not graded. And sometimes I've actually had required students to come to my office hours, and I'll ask them these things in person and have them walk through it. So it sort of depends on the size of the course and what I think is going to work best for the specific area. Good. Next slide, please. So after I've done this diagnostic assessment, I can make changes throughout the semester, sort of often more overarching changes. I also want to get feedback both for myself about how things are going, but also give feedback to the students on a regular basis about how they can improve. So I like how Abbe said there, they want to know, are they learning what they should learn? So I want to give them feedback on how they can improve their skills and in my course. So at Minerva, all classes, both our math classes and our other classes as well, they include 2 different types of daily low stakes quizzes that provide formative assessments to our students. So all of our math classes are taught on a flipped model. Students have to review material before they come into class, where we have active learning activities that they complete. As they come into the class, I want to know, did they understand what they were going to prep for that day? So I'll give them a preparatory assessment that's designed to gauge their comprehension of the key concepts that I know they're going to need for the activities that are coming. So one example, again, from a linear algebra class, I might have them watch some videos about the idea of a Markov matrix and how you can use that to model. And then I'll ask them the following question. You're trying to come up with a model for your laundry habits. On a given week, either you're going to do laundry or not going to do laundry. Write a Markov matrix that represents your own laundry habits and calculate the probability that you will be doing laundry 2 weeks from now. So this is, every student is going to have a slightly different matrix. I remind them to keep their probabilities greater than 0. But this lets me test, like, do they understand those ideas? After this, I'll pick a student answer that I'll share with the class. We'll walk through it together. And go through all the different ideas, and I can address those common confusions I see of those problems. Usually after that, my students will do a couple of different activities, often group problem solving sessions, And at the end of class, I'll do another assessment. So I want to see, have they made progress towards learning goals during that class section? So this is similar to the idea of a 1-minute paper that Abbe mentioned previously. But I'm actually going to ask them to do a problem usually. So for example, I might ask them to explain the relationships between eigenvalues, eigenvectors, and the long-term behavior of a Markov model. So I try to get into more of a comprehension of the ideas there. After class, if I have time at the end of class, I'll review this answer as well. Sometimes I don't. After every class though, typically students usually will receive feedback, directed personalized feedback to them on one of these 2 quizzes. So I'll grade their answer against a 5-point mastery rubric, and I'll give them a comment saying, you did this well, think about this piece here. So you explained to me the relationships between eigenvalues and eigenvectors well, but I want you to think more about how you can model and understand long-term behavior in the future. So I'll give them that personalized feedback. And I find that this is a great way for me to find those common confusions that I might want to address in the next session or send a message to my students about. Next question, or next slide. So if I'm not giving them feedback on one of their 2 quizzes, it's because I'm actually going to give them feedback on some sort of verbal contribution that they've given in the course. So all Minerva classes are recorded. And what I'll do is I'll review a portion of that recorded class session. So maybe it's a collaborative problem solving activity, maybe we're debriefing a breakout group where they did a problem set, or I might have students presenting solutions. And I'll look at the student comments, the verbal comments they've made, or maybe the chat comments that they've sent to me, and I'll give them feedback on how well they did this. I like this because it allows me to give them feedback both on how they communicate mathematics verbally, along with how they're communicating mathematics in a written format. So one example of an activity that I love to do in my classes is I'll ask students to rate a solution, either one that I've put together or maybe another student's solution on a very simple rubric. I got this from Sundstrom's book on mathematical reasoning. And the rubric is it incorrect? Is it correct but unclear? Or is it correct and clear? So students will give that quick rubric rating, and then I'll call on them to tell me why they rated it the way they did. So if it's incorrect, I'll say, okay, what do you think's the flaw here? How could you fix it? And then they'll tell me what they would do, and that's what I'll give them, I'll assess them on, like how well they identified the flaw and suggested an improvement. I can also do this if they say it's correct and clear. I'll say, what do you like about it? What about the structure here is strong, right? And then that allows me to give them some feedback on, how they're assessing the writing before them. And again, after the class, we'll assess the students' contributions during the activity, and then I'll send them targeted feedback that's tied to a specific learning outcome. Great. Next slide, please. So the first thing I talked about, the diagnostic survey, was really a way for me to get feedback on the students that are coming into my class to make decisions about what I'm going to do in the coming semester. Observing class recordings does the same thing for me. It allows me to see sort of overarching how my teaching is going, how my students are interacting in class, and make targeted choices about how I can intervene and help to improve the class culture, student learning within it. And maybe make potential adjustments for subsequent sessions. I also really like this because I can ask one of my colleagues to watch my class, and I might watch their class, and we'll pair and give feedback to each other. I've learned awesome strategies for in the classroom from watching my colleagues, and that's been really strong. It's also a great way for our new faculty that are coming in, that I can give them, I can work with them and give them feedback on how their classes are going and use for professional development. So this has been something we found really useful at Minerva. I think that's it. Thank you.
And Rena, there are some questions. I'm going to let you address them through the Q&A, and we're going to move on with Francis's presentation.
All right, I just want to spend a few minutes here talking about how I've used rewrites and reflection in some of my upper division courses. Next slide, please. So in analysis, which is the first course of students take where they really learn how to write proofs carefully. Of course, the course goals is to learn the content, but also one of the course goals is very clear to them up front, because we talk about it, is learning how to communicate math well. And just so you have some background, the students often come into the class with preparation that's uneven across the class. So for instance, we have students at the Claremont colleges. All the Claremont colleges are taking, potentially I have students from all 5 colleges taking this class, and some colleges emphasize writing in the freshman courses and some don't. And so what will often happen here is that I'll have some students who are really practiced at writing well and some that aren't. And I don't want to penalize students for having different kinds of backgrounds coming in. So one of the things that I learned from a colleague is allowing rewrites at the beginning of the semester on the first 4 assignments. These are optional rewrites. They're due a week after the homework's returned. And graders, one of the things, of course, you have to think through is if you have other people grading the class, they also have to be trained in what it means to write well and how to grade writing. Next slide, please. One of the ways that I set expectations in the class, both for my students and some of my graders, is I give them a handout on what good mathematical writing looks like. You can see here one example. This is a 3-page handout that my students all read as part of the very first assignment, homework number 0. And I asked them to answer a few questions on it. And by the way, if you want to find this handout and some of the other handouts I use in lower division classes, you can Google my name with Writing Math Well to find it. Next slide, please. And so I'll have them reflect a bit on this, have them read this writing handout, have them reflect by answering just a few basic questions to make sure they've read the assignment. And some of these are things, for instance, one of the questions is name 3 things a lazy writer would do that a good writer wouldn't. So it asks them to think a little bit about what they read in the handout and why writing, I try to emphasize it's a process and something you can always improve. And then in terms of how what happens with the assignments, next slide, please. I mentioned to the graders that they, at the beginning of the semester, they can be a little more strict on the grading because the students will have an opportunity to improve their writing. And often, if they're told that if they actually improve their back up, please. They're often told that if they are a little stricter at the beginning, it'll actually make their job easier as graders later on in the semester because the writing actually drastically improves over the course of the first few assignments. Scores can only improve, so students won't be penalized for trying to rewrite. And I have, as I mentioned, found that writing drastically improves when students understand what's expected of them. Another variant that I've used in my IBL topology class is having students write a joint solutions manual and revise each other's solutions. And so basically, one of the things they have to do in the class is over the course of the semester, write up 15 solutions and revise 15 other solutions. So revise other people's work. Next slide. I'll mention about reflection. I spoke about this at a previous TPSE seminar, but if you weren't there, basically one of the things I love to do that's really formative, I think, is help students reflect on what they're learning. And so I ask reflective questions on the exam, not just questions that ask them to solve problems. You can find this again by Googling 7 exam questions for a pandemic. I just wanted to show you a couple examples that I actually used this semester in a Galois theory course. One example, which I gave them before the final exam, was I asked them in basically no more than 2 or 3 pages, explain Galois theory to a friend who has a first course in algebra and has a basic understanding of polynomials. And I try to give them very careful instructions of what kind of answer I'm looking for. So I say basically, you're trying to give an overall picture. You're trying to provide conversational insight, which means giving motivation, but you're not trying to get into technical weeds. And then I give them specific things that they, I say your description should devote at least a paragraph to these elements. And I give them some examples. So here, part A is what can I learn from a polynomial by setting a splitting field, et cetera, et cetera. And so it should be pretty clear to them what kind of answer I'm looking for. And I have to say, this was basically 40% of their final exam, and all the students, by and large, did really well on this question. They actually provided many great answers and actually give me some perspective. So when I teach it again, how I might pitch the class, pitch the material to my students. So I actually learned something. And several students wrote me and said this was actually one of the best finals they've ever taken because it actually helped them to synthesize everything from the big picture rather than being forced to answer questions that under time pressure that they felt was focused on some narrow area. Next slide, which is I think the last slide. You won't be able to read all these answers, and I just thought I'd show you the kind of richness of answers that I might get for a question like this. So another question I used on the same final exam was consider one idea from the course that you found beautiful and explain what the idea is and why it's beautiful to you. And again, I gave them specific things that I'm looking for in the answer. It should A, explain the idea in a way that could be understood by a classmate who's had first course in algebra, and B, explain how this beauty is similar to or different from other kinds of beauty. And again, I hardly had any answers. I think all the answers were very, very nice, very reflective, and had something very interesting to say about the material in Galois theory and how it compared, using analogies to art, using analogies to human relationships, and using analogies to complex machines. Well, anyways, I don't have time to go into it. But the point is, these are all wonderful answers, and it helped me for when I teach the course again to think about the kinds of analogies I might use in class. I'll end there. Thank you very much.
Thank you, Francis. And thank you for making us think about being reflective practitioners. Next, we'll hear from Shell, who will talk some more about formative assessment.
So one of the things, thanks, Dan. One of the things that we've talked a little bit about is that the purpose of formative assessment is to help faculty recognize where students are struggling and to address some of those problems immediately so students can improve. But one of the other purposes of formative assessment is to help the students understand where their strengths and weaknesses lie so that they can become better self-guided learners and lifelong learners. And Nancy, would you go ahead and advance the slide? Thanks. So self-assessment, formative self-assessment allows students to focus on their own work, not the work someone else is doing on the board or that their instructor is presenting, but what is it that I'm doing and what do I understand? Where are my strengths and weaknesses as I'm moving through the content? It helps to target areas that need attention, depending on the kinds of questions that are asked, and help students figure out how they learn. And of course, this information can be shared with the instructors in the classes so that they can also help the students grow in some of these methods and help the students identify ways to improve their own learning. So the overall goal, of course, is to make sure that they've mastered concepts and that they can attack concepts and content outside of the classroom and outside of even our mathematics classroom overall. So how do we help students learn how to learn is the goal of the self-assessment, formative self-assessment. Please advance the slide. So there are a whole variety of self-assessment tools, many of which have been mentioned in one form or another by my colleagues already. I'm going to come back to the learning logs in a moment, but that connects very nicely with what Francis was talking about in the reflections and the questioning pieces that he has the students work on. An option for self-assessment tools is a self-report note. As a student finishes a homework assignment, for example, have them go through and identify while they were doing the assignment, were they overall confident? Did they feel like they could explain that information to a classmate? Could they teach somebody how to do what they've just finished doing? Which is where we would hope students after some time have gotten to. But in their self-report note, maybe they also identify that they could do some of it, but they couldn't do all of the homework or all of the assignment, and then to explain where they found the difficulties or what the challenges were, and help them to think a little bit about why that was challenging. Maybe students have identified that they thought they were okay when they left class, which I think we've all heard many, many times. I understood it before I walked out the door, before I left my computer. But when I started the homework, it didn't look familiar anymore. Well, why is that? Let's ask that question as well. And then there are some students who, not during class or not in front of their classmates, will give you an indication that I didn't understand what you were talking about it while you were talking about it, while we were talking about it in class. And so explain where those difficulties are and help the students think about where those things happened. And again, we can provide some assistance to students to improve their learning. And you can do that throughout the term. You can do that in a face-to-face class or online. A pause is nothing more than taking a short break. It's oftentimes suggested 3 minutes to let students reflect on what's happened so far. What questions might they have? What particularly clicked with them? Does it relate to things? Can they see how it relates to concepts that have already occurred? I'm going to come back to the classroom response systems and the clickers, as I think most of us tend to call them, in just a moment as well. But I think Rena alluded to some of the effectively a thumbs up, thumbs down idea, in that a correct, incorrect, or it's unclear, a way of indicating my comfort with a particular topic. A quick nod, the exit strategy, the exit question that I think Abbe mentioned briefly, traffic lights, red light, green light, yellow light, I understand, I'm unclear, I need more work, are all ways that instructors can get quick feedback from students, but students can also take a moment to think about, where am I in relationship to the content? Nancy, would you advance the slide? I said I'd come back to learning logs. Many of us might call it journals. That might sound familiar from somewhere. My experience is that when students think of journals, they think of composition class, and they think of multi-paragraph, multi-page expositories. And a learning log, I log my time for a variety of things. I log what I eat, maybe if I'm on a diet. A log is quick and it's informative and it's for me. And so prompts for a learning log might include things like, how do I as the student organize my math notes? How does that help me? If they think a little bit about that at the start of the term, maybe they recognize that they have some improvements to be made, or maybe that things work really well for them. If you pair students together to share some of those responses to those questions, they tend to learn some additional tips and strategies from each other on how to be successful and how to make sure that what they need to learn and what they need to reference is available to them. What did we do today? Why did we do it? Why? To think a little bit about it. How does it connect to what we've done before? How can it be applied? Do I still have questions? And you can always probe, what kinds of questions do I have? Students oftentimes are resistant to writing in a mathematics class, but by thinking a little bit about what am I doing and how am I doing it, putting our thoughts onto a piece of paper. I don't need them to be complete sentences necessarily. I certainly don't need them to be a perfect spelling. I'm interested in what you're thinking about the learning that you're doing. And you know, as you go on, perhaps you model differently, or you can also have students share in different ways. But as they progress from start of term to end of term, you can alter your expectations a little bit. Maybe you ask these questions less frequently, or maybe they become more formal. Or in Francis's case, perhaps there's some writing that's a necessary part of your final exam, and there are expectations there, but they've been writing all along. And so they've gotten a little bit used to that idea and to sharing with you what it is that they think, so that they don't feel so vulnerable in admitting that I still am unclear or I'm having difficulties. learning prompts, learning logs are one way to go through and have students think a little bit about themselves and their own learning and the content. But some of us employ polls or clickers in class, and please advance the slide. But classroom response systems, clickers, are another way to go through and have students do some self-assessment. There's a couple of quick questions here. Entry-level types of things. There are many, many more examples that you might find, but you know, from calculus. If the second derivative is equal to 0, then there's an inflection point at the point A. True or false? Well, there's an awful lot that students can think about in that question, even though they've got a 50-50 chance of guessing the right answer. But if my point in asking this question is to the student, do you understand what's happening here? Many of them are, by the time we've gotten to a second derivative discussion, quite comfortable telling me, I really don't have any idea how all of these pieces fit together, or I'm pretty comfortable with what you're asking me here. I'm comfortable with the notation, I'm comfortable with the terminology. Is the following from differential equations? Which of the following is not a differential equation? Can I pick something that is and isn't a differential equation out of a collection? I've had more than one student in 20 odd years who has gotten to a point and they can't identify which one isn't a differential equation. It's a differential equations class, so they must all be. And therefore I try to apply the techniques to anything that comes my way. Is it homogeneous or not? In an algebra class, you know, is this a term? Is this a factor? To help enforce vocabulary. So I think there's lots of different ways that we can use the response systems to help folks understand what's happening and gauge where they're at. Other prompts include things like, I'm comfortable with, I'm not comfortable with, I think I understand this material. I'm ready to move on. That's a nice one midway through class on a clicker system, to just take a poll from the class. I'm ready to move on to the next concept or not. And if not, why not? We can follow up. Some quick and easy feedback there. Nan, would you go ahead and advance the next slide? Thanks. We've got lots of good things to talk about, but I do want to make sure that Kate has time to share with you. So Kate, please.
Well, and actually, Shell, I just want you to address how you could use things such as thumbs up, thumbs down, and other items remotely.
So depending on what your access is, if you're using a program where you have the hands up or the hands down feature, you can raise the hand for a thumbs up or not. Some of the systems allow you to do a thumbs up or a thumbs down. I've shared emojis so that students can go through and share my thumbs up or thumbs down emoji in a chat room or in a discussion room. There are lots of other ways you can do thumbs up and thumbs down if you'd like to. A keyword instead of the thumbs up, thumbs down, yes, no, okay, no. I think those are some of the things that are there, and it depends if you have video or not too. If you're small enough that you can connect via video and you can see your participants, the thumbs up, thumbs down is kind of nice to just go through and take a look at quickly. But if you've got a large group, I don't have a hope of seeing most of you in the tiny window that shows up there, then I do need something that comes via chat or Poll Anywhere or one of the other polling softwares that's out there.
Okay, thanks, Shell.
Thanks.
And now our last panelist, Kate.
Hi, so it's nice to join you today, Nan. Well, I'm going to be talking about just about micro tests because I think my colleagues have covered a lot of the information. Just for a little context, go ahead, Nan, go to the next slide. I teach a Foundations of Mathematics class using this, but many people would call it a proofs class. I like to call it a reading, synthesizing, and communicating mathematics, which you'll notice gives me free range to ask people to write. So you'll notice I had a fairly traditional class when I started teaching this back in 2005, written homeworks, a couple of midterms, and a final. I thought I was a hero for adding those journals and presentations, which made it much more. We had a cycle by which those journals were perfected and the presentations, so just reflecting what my colleagues have talked about. But I was still frustrated with the class. I had too many people who I discovered were struggling too far in. And that's when I went whole hog in, if Nan, would you forward the slide, for what I call micro tests. So I replaced those orange midterms. Nan, if you can put the slide forward. I replaced those midterms with these micro tests, and I call them micro tests on purpose, because what I did was I thought carefully about what were going to be the summative signs of somebody having accumulated the knowledge that I was after in the testing venue. You know, I have other venues where I can measure other things, but in the testing venue, what were those summative things I was after? And what I basically did was I distributed them across the semester in very meaty but very short assessments. So those would happen every other week. And moreover, if the student was not satisfied with the result, they could redo that test the following week. So the test could be on, the one that you see in front of you is on equivalence relations. And if you go forward, Nan, you'll see one on induction. So a full induction problem with a full proof and maybe a follow-up question, 10, 15 minutes, would be given every other week if they, and it was graded mastery. So 1, thank you for coming, 2, a solid effort, 3, almost perfect, 4, perfect. But I felt that I could grade on that measure because if they weren't satisfied, they could come back the next week and do another induction problem, obviously not the same one, during my office hours. And I was terrified when I did this because I wasn't sure that they would be able to take all of these small pieces and bring it together into a cumulative final assessment, which was required under my department's rules. And I'll show you a little bit of data in a second that shows that this risk was worth taking. Nan, if you could go to the next slide. But it's important to understand what the context of these micro tests were. So Nan, go ahead to the next one. We had the weekly written homework assignments. Those were turned in on a Wednesday and returned on a Monday. We had 2 cycles of this before we had a test. That material would feed directly into the micro test, or quiz, which was based only on the returned homework. So in other words, they've had 1 round of formative assessment through the homework. Now we're having another round. If you're not satisfied, I grade that quiz right away. You get it back on Monday and you have a week to redo that same topic in the micro test environment. If you could go to the next 2 slides, Nan. I made sure to balance the workload across the cycle of learning. So the biweekly journals and presentations were not in conflict with the micro tests. And this cycle meant that every 2 weeks, I would have a really solid idea of where all my students were at. And more importantly, to the metacognition question that was out there, my students knew where they were at. They were aware of this cycle. It was transparent, it was predictable, and hence equitable. The students could reflect very early on in the semester and make corrections to how they were working. And I could be very specific in my advice to them, but very often they were much more aware of what their learning is. I would have in the journals reflections on what were you going to change this time in the next cycle. I also have them ask to reflect upon how I was teaching and why I might have done something in one way versus another. What was I trying to get them to do? So reflective questions to tie those, to make this cycle transparent to them and why I was asking them to do it. Because honestly, as a student, I think I would have hated it myself. So I was trying to give them a reason to buy in. So what was the outcome on these? So Nan, if you could go to the next slide. Before I started the mini tests, so basically I've been doing this since 2005, on and off. Up to that point, I'd had very small classes and pretty mixed results. So there are the midterm scores as compared to the total average. And this is the data that backs up my frustration. I mean, the idea that there are all those people scattered all over, sort of like somebody just shot a shotgun at the graph there was exactly what I was feeling about my students, that I was losing too many of them and I was only finding it out at a point where I couldn't help them correct. So Nan, if you could go to the next slide. Since 2005, I've had 291 students. The attrition has not gone up with these micro tests. In fact, it's gone down. We went from about 2.6% to 2% attrition. And moreover, you see a much more of a solid group up in the upper right-hand corner where the micro test scores are strong and the total average is strong. The total average, remember, includes a 30% counting for the final assessment. And you can see there's a much stronger correlation between the micro test score and the total average. Nan, can you go to the next one for me? Here is the more recent 110 students from fall 18 onwards. I'm getting a little better, right? Easing all these things together. And you can see, because there's fewer dots, you can sort of see how they're spread out there. And this reflects exactly what I was feeling, that I had fewer and fewer students who were getting lost early on in the semester, or sometimes there's ones that get lost in the middle of the semester. Because we have essentially 2.5-week cycles, we can correct many times during the semester. Somebody's mother gets ill, something's going on. I can detect it quickly and we can work on it quickly. Nan, if you could go to the next slide. Because a valid criticism of these data is that I was comparing microtests to the total final average as opposed to the final exam, right? Because the microtests were involved in the total final average. And here you see much less correlation, but you still see what I was observing in my students, that prior to when I was doing midterms and a final, I still had that scatter pattern between how well they did on the final versus how well they did on the midterm, or vice versa. When we move to the microtest, it's still a scatter pattern, but it's almost all in the upper right-hand corner of the graph. And that really reflects my experience in the class and the experience that the students are having. Now, Nan, if you go to the last slide, what I want to point out is that this worked very well in the online environment. If you have a synchronous moment in which you're teaching your class, I was using Zoom. So Nan, if you can go to the next two. I was having a synchronous meeting with my students twice a week, and I was using guided lecture notes that I'd been using, that I always use an iPad and a pen to fill them in. I always share those with my students. So what those allowed me to do was to either do that again during Zoom or prepare pre-lectures, and we could do more group work during our Zoom meetings. And then we would dedicate the last 10 to 15 minutes of the class to these micro tests. And if we had to do makeups, I would do them before or after the class met or at other times. And because I wasn't commuting and I could do it from home, it wasn't hard for me to arrange to deal with about 38 students doing weekly quizzes, grading them and getting them the feedback. And I found that I had much less cheating in my class than my colleagues did in their other upper division classes, because students really felt like they had a good chance. They felt it was fair. They felt that they knew what to expect. And when we got to the final, they really had a solid idea. I had to revise the final, and in fact, I revised it, I think, based on Francis's presentation some weeks ago, in which instead of asking them to do an induction proof, I asked them to correct an induction proof. So thank you, Francis, for that. I want to leave us with a couple of seconds for Nan to wrap up. So thank you for including me.